this is the big last finale dealing with real life issues. Alright, so yeah, y'all, we about to go ahead and put up your dukes and it's time to brawl. Because throughout the year, you was taught all these beautiful skills. Now, it's time for you to come in swinging because we're right at the end of this. Alright, let's get to it. Remember, numbers are so powerful that they define you, can help you survive, they can handle you, they can also be used as a weapon and worse than rumors. I mean, say for example, a fight, if you got 10 people want to fight you, that's worse than someone spreading a nasty rumor about you. I'd rather for the rumor than to get jumped by 10 people. Just a food for thought. Alright, let's go over the precise definition of mathematics. By now, you should know it. If not, I'll go over it with you again. And remember, this is something that's on the test. The technique to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. We've been talking about this definition. You should know it. And if you don't know it, there's literally no excuse for you not to know it. Because you've seen this a lot. So, if you watched the previous videos about this definition, you should know this by heart. So, we're going to see what's up. Alright, announcements. I may not even talk about this. Alright, get project done ASAP. Fix those mistakes. 21s and above are finished today in class. 18s are finished on the 8th of May. Scoring an A without 18 is required for you to take the final, but a variance and an easy finish. Unapproved, unapproved use of phones and internet hinders your grades. Homework always turn in ASAP without an 82%. Without the 82% C before taking the final put you at risk of failing. Skipping my final will knock you 2-letter grades. Alright, working doing testing. Some of you guys got smart and you took advantage of what was there. Other people like put work in. Okay, so what about Project 7? You guys haven't touched on Project 7. I gave that to you guys early April. So if you choose not to do it by this time, it is what it is. But that is going to be worth the hefty points. For those who wasn't assigned Project 7, like my first period class, I gave you pretty much something similar, which is relaying you for the final. 18s and 21s do not have to take quiz or test. They are always exempt. Again, about the math ACT 21 score, I already said it earlier. And also, alright, to ensure success, show respect, handle your business. If you feel like learning, remain quiet and out of dodge. Flashing out does not help, it hinders you. Without skill, none shall pass. Keep those things in mind. Alright, now we're going to get into the heart of the lesson. Modeling patterns in the environment. Alright, go again with the precise definition of mathematics. is the technique to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and monitoring patterns arising in the environment. Keep those things in mind, please. And again, I'm saying the same thing over and over and over again. You're not getting it? Well, functions reviews. The stuff that we did throughout the year. Let's go over these functions that we did throughout the school year. First, we have linear. Linear was part of the regression we did, and we did a lot of this in Algebra 1. We did it a little bit in Algebra 2, not too much because we know linear. The function to the right is a rational function. The two of those are inverses of each other. Alright? So the domain is all real numbers because the graph keeps going from negative into the positive. Same for range. X, Y intercepts both to be 0 because it's right here. It's an odd function because it's symmetric around the origin. And the equation is the slope in the self-form of y equals ms plus b. Rational functions. The domains are written differently because you got negative infinity to 0. Get close to 0 but doesn't touch it. And then it picks up again from 0 to infinity. And this U shape is just telling you I got two graphs, which we know this already. And lest I forget, this function is an odd function because it's symmetric around the origin, and the equation is called a reciprocal equation. I'll be asking you a question, why do we call it reciprocal? So if I have x, what's the reciprocal of x? And that should answer your question. Will answer my question. Alright. The equation to the left is quadratic and its inverse is square root. So the domain is all real numbers. And then the range is 0 to infinity. Now here I wrote it as a bracket. Why did I do that? Because it's actually touching 0. So anytime a graph touches 0 or any number, therefore you write it with a bracket instead of parentheses. That's going to be crucial on the final. Again, you have x and y intercepts right there. Vertex is also right there. And the vertex is the highest or the lowest point of the graph. It has a max and min. It is an even function because it's symmetric around the y-axis. Alright, and this is your standard quadratic equation. That's the name of that, standard quadratic equation. Alright, square root. It has a domain of 0 to infinity. Also have the same thing as 0 to infinity. It don't really have a xy intercept. It depends because it touches, but intercept means crossing through. So this does not cross through x or y. It touches at 0, 0, but doesn't cross. And this is just, of course, a square root equation. There's no fancy name behind that. And it's not even or odd because it's not symmetric. And these are not symmetric either, but I bet you guys know these by heart. Exponential. And what's the other one? Logarithmic. So, the domain is all real numbers. Domain is all real numbers. The domain is all real numbers. The range is 0 to infinity. The range is 0 to infinity. The x-intercept, Rarely will it have an x-intercept. The only time this will have an x-intercept is when we are solving for a exponential equation. That's when it have an x-intercept. A y-intercept, it's always going to have one. It's going to be, for this basic one, it's 1, it's y equals 1 or 1 comma 0. But because it has a y-intercept, well, actually, not because of that. Because the range is 0 to infinity, and notice how I put parentheses on there because it's not really touching 0. It's getting close to, but does not touch 0. It's getting close to, but not touch the 0. It is a horizontal asymptote. Horizontal asymptote. Because it has a horizontal asymptote, the horizontal asymptote is actually going to be 0. And the equation is your basic exponential. Alright? So logarithmic. So the logarithmic is exact opposite. So each of these graphs that we have seen so far are opposites of each other. So logarithmic has a domain of 0 to infinity. And because that domain is 0 with the parentheses, it has a vertical asymptote. Vertical. Logarithms have vertical asymptotes. Exponential has horizontal asymptote. It's not going to really have a y-intercept unless we do something with it in terms of transformations. And the equation of y equals log bx. And that's standard log. Alright? And once more, pay attention to the brackets and the regular parentheses. Again, with anything with an asymptote, it's going to have a parenthesis because it's not going to touch at that value. Alright? So I know you guys should be familiar with these. Sine and cosine. We don't really touch on tangent. You will see that in pre-calculus though. The domain is all real numbers. The range is -1, +1, because it bounces between -1 and +1. It has a x and y intercept at the origin. It is an odd function because it's symmetric around that origin. And the period is 2 pi, and it's an odd function, and it's sine x. Cosine, very similar. Again, each graph is opposite, and when it's opposite, it's even function because it's symmetric around the y. And they have the same thing, periods, and this is just cosine. And rarely will have an x-intercept. If we are solving for cosine, we will have an x-intercept. Mathematics is used in two ways. Abstract, which is thinking and logic. So all the stuff we did with the functions is the abstract math we did. Apply this skills for the jobs, applying for situations. Right? Again, if it's not talking about a real life situation, it's abstract. Well, that's one way of putting it. But to be truthful, if it doesn't give you an integer or a real number answer to some type of equation, it's abstract. But for our purposes, if it's not talking about real life, it's abstract. Alright, and those are two examples, log exponents and customizing license plates. Alright, it's Kahoot time. If I got a Kahoot out there, see what you can do with it. hopefully, this guy in the white and black gloves is you knocking down that Kahoot. The Kahoot is on the ground. You are standing tall because you are victorious, smart, and very hardworking. Now let's apply everything that we have did throughout the year and apply it to these situations. Now, do not forget, don't forget, you are given the equations when it's dealing with real life most of the time. But when you are not given that equation, it's mainly because it's so simplistic. It's not really hard. But most of the time, when it's Algebra 2 level, you are given the equation. You gotta find x given y or y given x. It depends on the dependent or independent variable. You must know that. And do not forget to give it a complete thought. So these are three things that we have did dealing with other things. So remember, because you are still dealing with algebra, you are dealing with x and y. Y depends on x. So time and money. Money depends on time. Without time, you can't make no money. So that's why I want to. So that's what you gotta keep in mind for these problems. All right. Now with that said, let's get to it. All right. This is a study that deals with responding to negative life events. So these are situations where something tragic happened. This is how you deal with them. And this is how psychologists determine if you are depressed or not. As I told you, I think it's pretty much down to a numeric. So, groups averages level of depression in response to negative events. So, we're dealing with the sense of humor. So, usually, people with low sense of humor who doesn't really laugh have a high level of depression, which, that makes sense. If I'm depressed, I'm not really have a whole lot of humor. But if I am laughing all the time, chances are I'm not as depressed as one would think. So these are those equations that we're going to be using to answer some following questions. So in real life, again, you're taking equations that are given to you, and you got to answer questions. All right. If the high group averaged a level of depression of 3.5 in response to the negative life event, what is the intensity of the event? And again, you're going to get the equation. So, once again, x and y, dependent, independent. So, what's dependent? The level of depression. Because your level of depression depends on the intensity of some negative event, which is your x. So, we got it. That's your y, and that's your x. See, your depression is your x. Your depression is your y. The intensity is your x. So let's do it. So we know that we are given the y value, the dependent, which is the depression level, but we're trying to find the intensity of some negative event that we was there with, which is your x value. So 7/2 or 3.5, however you want to do it, wherever works in decimals. Plug that in for your d and just solve the equation. Decimals will give it to you, but I'm going to ask you on the final, kind of show that work by hand. So put it in, plug it, da, da. So, and we know that 11 divided by 2, x going to be 5.5. So remember to put in complete thought. The formula indicates that if the high Herman group average the level of 3.5 in response to a negative event, the intensity of that event is 5.5. Now dealing with the asymptotic example. Rational functions are not often too talked about in the classroom, nothing like that, but within time, we're going to get through this. So, suppose a French company that manufactures a Renault, or Renault is a French looking car, which you could Google it and you'll see pictures of what that car looks like, has a fixed cost of $1 million, and that it costs $5,000 to produce each car. And when I say dollars, I'm thinking of the European currency. But in this purpose and case, we're going to keep it with dollars, alright? So A, write a cost function, C, of producing X cars. B, write the average cost function of C of producing X cars. C, find and interpret C of 1000, C of T1000, C of 100,000. Then we're going to write asymptote for the graph of the function cost. The average cost function Z. Describe what this represents for the company. Now, that was a lot. So let's take a deep breath, slow down, and we're going to get through this. As I have told you before, I am going to give you the equations that you need to consider. So you have all the details you need. Alright? So the cost of function Cx is going to be the fixed cost times the cost per unit and the number of units made. That's what C and X represent. C is the cost of per unit. X is the number of units made, referring to cars. And remember, we're using dollars because that's the money that we know. So we're not going to use the word euro. Okay? Euros are not being talked about in this. Alright? As I told you, we're going to go through this step by step. I'm not trying to go fast. I'm not trying to go slow. I'm just trying to get you what you need so you can keep going. Alright? So A, write a cost function C of producing cars. X cars. So again, here's the situation. A French company that manufactures a Renault has a fixed cost of $1 million and it costs $5,000 to produce the car. So when you doing these word problems, obviously, you could underline. So fixed cost plus CX, which you know the fixed cost is going to be what? 1 million because you're plugging it in, and the the cost to produce the car, which is C, is 5,000. And that's all you have to do. Okay, so let's write the average cost function, C, of producing X cars. So these numbers that I took, going back to the formula that we used previously, I just took this and put it over X, because that was the formula that was given to us when we first started the problem. Alright, so go back to the beginning of this problem and take down that formula and just do what I just did. I got the C of X information right here, and that's just that. And you notice that my C's are different. This is a curly C. C, interpret when C is 1,000, 10,000, 100,000. And this is your average cost function. So that curly C is the average cost function. So that's the difference between the C. This regular C was cost function, and the curly C is the average cost function. So please review the video before you continue. So stop, go back, get those formulas that I gave to you before we got started, and now let's put it together. So this represents the X value, and you just plug it in. So when I plug this in, I get the 6,000. When I plug this again, I'm getting 1 to 5,100. And then when I plug it again for 100,000, I get to 5,010. So what do we notice about this? What is it getting closer to? By looking at those three numbers, it's getting closer to what number? It's getting closer to 5,000. Alright, so now we gotta write a horizontal asymptote of the graph of the average cost function. So again, we took the average cost function that we created for B. And now we're going to find this asymptote. Put this in decimals before it get close to, but doesn't really touch. And you realize it's going to be 5,000. But if you don't want to go through decimals, you don't have to do all that in decimals. So why don't you just take this? Going through the three rules of horizontal asymptote. So because they have the same variable that has the same exponent, cancel them out. So it's going to be 5,000. Now, as I have told you, everything will be in complete thought. So the horizontal asymptote is 5,000, which means that the more cars produced each month, the close the average cost per vehicle for the company is 5,000. So let me use this in clearer English. The horizontal asymptote of 5,000 means that the more cars produced each month, the closer the average cost per vehicle for the company is $5,000. So, you guys are no stranger to this problem because we dealt a lot with money. So, I'm just going to go over it fast and move on. So, here, you got Nate trying to open an account with $70 and he gets 5% interest rate. To the nearest penny, how much money we has 3 years. So, the formula is given to us. B is the future amount, which is your Y variable. Your principal, your 1 plus your R to the T, all that's going to be your X value. Because all that depends, all that's independent, and your future amount depends on all those factors. So, putting in decimals like that, 5% is 0.05, not 5. To its nearest cent, the balance would be $81.03. The Richter scale. We talk about earthquakes a bit. So earthquakes measure with the wave amplitude of 392 times A naught. What is the magnitude of this earthquake using the Richter scale to the nearest tenth? Make sure you have all those values together. So again, I'm going to give you the equation always, no stop. So you plug this in, the A naughts cancel, so log 392, all you have to really do is log 392. And you found out that the magnitude of this earthquake is 6.6 on the Richter scale. And that is how you answer that question. Alright, what is the precise definition of mathematics? It is the technique to explain, understand, and manage reality by ciphering, countering, measuring, classifying, ordering, inferring, monitoring patterns arising in the environment. So y'all, I'm not making no more videos at this point. I'm pretty much done. I just want to do this last piece video, so no more of the school year, and we're gonna leave it as that.